Einstein said that you don't need to know everything, you just need to know how to find it. And another famous person said, beat it or join it. We are probably unable to beat the technology, so we should learn how to join it. If you want to know how to draw insight from knowledge by leveraging AI tools, either in your day-to-day life or in your company, well, this video is made for you. Let's get into the notebook. We have a RAG system here, which at the end of the day is a machine learning project. So we need to review the machine learning pipeline here with each other. This picture is from my machine learning design pattern and principles ongoing tutorial available here, in which I have elaborated on different phases that we have here, but here I won't go into the details. We have project management phase, and then we set up environment, we handle data, we design the architecture, we train, most of the time we fine tune, and then evaluate driver function, which a function which takes care of everything and put together all different parts of our model, and deployment, in which we deploy our model in production and also maintain that. Project management part. This has a unique and important question, which is what is exactly the reason and the question behind these explorations using RAG. I recently went to an event called Adventure. Alright everyone, it is the last day of having fun here in Calgary. How are you doing, Osaso? How did you find the event?
It was fun, it was entertaining, it was full of networking, buffet, breakfast, lunch and dinner, danced, partied.
Oh, dance, I love that. And it had around 200 sessions about AI, innovation and technology, and I could only participate in 20 of them, and at the end of the event I tried to come up with my own big picture, with my own summarization of the whole event, so that I can have an idea about the emerging technologies and how I can use them in my own field of study. So I came up with this elegant and beautiful picture, and it helped me a lot, but I was wondering to what extent AI systems, especially information retrieval systems or retrieval augmented generation systems, are capable of comprehending the information or forming a summarization or answering the questions. So in this video, we are trying to explore this question, and based on the sessions data of inventors. The most important second part to mention is all the exploration that we have here are for educational purpose, and if you want to use the Alberta Innovation Sessions data, you have to refer to the most recent privacy page and abide by all of the rules that they have over there. And my AI system, when they are summarizing, they might alter the information, so the only resource and the only reference for the information about the inventors sessions is this website and nothing else. Thanks to Google Colab, we don't have too many things to discuss in this part. You just need to run these cells, and also make sure that you have all of your keys as an environment variable, or if you are on Google Colab, you put them here, and then you will access them in this manner. This is the best practice, instead of having your key, your credentials available and visible to everyone here as a string. To scrape all of this information on the Inventors Sessions webpage. And the information was the category name, the title of the session, and the description of the session, and also the name of the speakers with their position and the company in which they are working. So I had multiple options. One of them was using online tools, which is a web extension that you use for extracting the information of websites, but they don't usually work and it's very time consuming to set up, and there is a high learning curve. And another option was Diffbot API. It is an API that you go and then you put the link of the website that you want to scrape, and then you specify the type of the information. For instance, here we had a list of information, a list of sessions that we need to scrape, and then you click on run and it will work. But in this case it was not working properly because this is a complex website and Diffbot was not able to accurately scrape the whole website. So I was trying to come up with an idea that can help us in scraping the data, and I was telling myself, Reza, think out of the box.
I just hit a lick with the box, had to put the stick in the box.
Thinking, why not just going and clicking on save the page, and then I saved the page, and I was so lucky that the data was already rendered in that HTML file, and I could run a Python code for scraping that data by using Beautiful Soup library. Alright, let's discuss the model here. I'm using Raptor. To simply explain it, this model starts over your initial document. You may have a lot of documents with a lot of different types. For instance, 20 documents from your product A and 100 documents from your service A, and so on and so forth. So Raptor will automatically cluster your document, and then for each cluster it will generate a summary so that you can have a better idea of all of the documents that you have. And then it will continue this process to end up with one cluster, and at the end one summary which has the holistic picture of your documents. And at the left side, the initial documents, we have the fine-grained details. So this is a nice combination of all of the details and also all the holistic picture. And then we store the initial documents and the summaries in our vector dataset, in which we have the vector representation of the information that we have, that helps us to fetch the relevant information faster. Deployment and maintenance. In this part, we will put together different pieces of our model and our different functions that we have defined so far. And I have brought the sessions txt from my GitHub repository. You can download them here. It is accessible publicly. And then we run the code to see the second document. So all of the documents are, each document is one of those sessions, and this session is the second one, index 2, and is a keynote session, keynote category, and the title of that session is opening ceremony, and Dr. Marcus was one of the speakers. So let's go and check the session. The keynote category, opening, the title is opening ceremony, and Dr. Marcus was talking with this description. So all of the documents are corresponding to the sessions that we have here. We have around 186 documents or sessions. And then we calculate token count for our sessions or the documents that we have. Why do we need this? We need this to see whether in our Raptor model there is a possibility or not to get out of the context window of our language model used for summarization of the clusters, because when you cluster documents, they might go over the context window of your language model. So having everything loaded, we then define embedder from OpenAI, and also we establish our connection to OpenAI API for using GPT-3 model, GPT-3 Turbo. Then, so you can run this line of code to form the hierarchical tree, the raptor. I have already ran the code and pickled the result. I'm just loading the result here. And let's take a look at the result, the raptor. So the raptor should be a hierarchical tree of our documents, the initial documents, and also the intermediary summaries, the summary of different clusters of different levels. So the last layer, we have three different layers. If you take a look at the last layer, we have a summary here, which is let's read the summary. The documentation provided offers a detailed summary over various sessions, networking opportunities, dining experiences available at the event called InVentures. It covers topics related to technology, innovation, entrepreneurship, agri-food sustainability. It is doing a pretty good job. It is pretty much, let's go to the initial question that we had. It was the summary that I came up with that, and the holistic picture that we have here generated by Raptor, it is doing a pretty good job in summarizing them and also giving us a big picture. But let's don't forget that when I, as a human, generated this summary, I had extra information, meta knowledge about the word, about the implication, application of different terms that I have brought here. But this language model is not allowed to use anything more than this. So let's also take this into the consideration that my beautiful and elegant picture here is a little bit outperforming the summary here because I also had extra knowledge about the word, but the language model doesn't have that and is at this case not allowed to use any context other than the context that we are providing. And also we have two other layers. In the second layer we have 8 clusters, and in the third layer, which is the last layer that we have 43 clusters. So, and for each cluster we have the summary of the cluster. So let's go and see one of the summary of one of our clusters in the second layer. So the first one, index 0, the documentation provided gives a detailed overview of the registration process for the event called InVentures, and it outlines various networking sessions and launch options available at the event, such as breakfast bites and networking. And additionally, the documentation includes details about the 2 receptions held at InVenture. So it is talking about the breakfast and also the break events that we had and the registration. It is forming a pretty good cluster because those sessions that we had, breakfast and registration, they are pretty much under the same category. So let's discuss another one. So the third one, let's read that. The documentation provided outlines multiple sessions held at InVenture under the category of live long, live well. Under the growing up food tech farm to fork category sessions focus on innovation and technology in the agri-food sector. And yeah, so I think this clusters is putting together all the documents related to agriculture and health and healthcare, and it is doing a pretty good job in summarization and narrating everything like a human in a very coherent, cohesive way. And yeah, so it is doing a pretty good job in coming up with the summarization and clusters. So, and then the next step is storing in the vector dataset that we have. So having these documents, we set the initial documents and the intermediary summaries to our vector store. And there is one hyperparameter. When you ask a question from your vector DB, you ask one question, for instance, tell me about the inventor. It has to retrieve the most relevant, the closest neighboring documents to your question in the vector space. So we have one hyperparameter, which is the number of documents that you retrieve, or the threshold for the probability of or the similarity of the documents. So in this case, the retriever function has a default value for the number of retrieved documents as 4. It retrieves 4 documents. We can change that later based on the use case that we have, based on the case study. The next step, once we have the documents retrieved, we pass the documents as a context. The retriever, whatever we retrieve from vector DB, we pass as a context, and also the question to our model. We also format that with a prompt function. The prompt function pulled from here, one of the libraries, it formats your this information. For instance, it adds one sentence at the beginning, like okay, ChatGPT, you are a very helpful assistant. Please, based on the context that is provided in the next line, answer the question. So it formats the question, the data that we have sent that, and then pass it to the next part of the pipeline. The next part is passing that to ChatGPT, to OpenAI API, or our local language model, and then it will answer the question based on the context, and it will return that. All right, so let's ask a couple of questions. Tell me about the topics discussed at InVentures. The topic discussed at InVentures include technology, innovation, entrepreneurship, policy, healthcare, agri-food, and sustainability, AI, quantum computing, IoT, e-sport. I didn't cover e-sport, because I couldn't attend those sessions. I had only one body, and I could not attend multiple sessions at the same time, so I missed that. But a language model is capable of consuming and comprehending all of the data at once, and doesn't have that limitation that humans have. Animal welfare, and so it is doing a pretty good job. Let's ask another question about the session that I attended. It was a session in which David, a great speaker, was elaborating on the metric that they have defined for sustainability measurement. So was any metric introduced for sustainability measurement? Yes, a metric was introduced for sustainability measurement in the session titled Measuring for Success. Let's see, measuring for success. It is retrieving the documents correctly and answering that in a perfect way. So let's see if we pass that to our vector data set. What are the documents retrieved for answering this question? So if we pass that, as I told you before, we retrieve 4 documents, and so it is probably one high-level summary that is retrieved, and another one is also a high-level summary. Another is a high-level summary, and at the end we have so let's see if we have measuring for success. Let's see how the model answered this, found the information about this part. Okay, so the first one is not actually the high-level summary. The first one is the document that we had for this session, which includes all of the information about this session. So it is doing a pretty good job. The closest neighbor was exactly the document or the session that was exactly about this topic. And let's see if we have the exact term sustainability measurement in our document. So as you see, we don't have the exact term for sustainability measurement It is doing a semantic search. It is not just looking for words or the different phrases. We don't have sustainability measurement, but this topic is semantically about sustainability measurement in that area, which was agriculture. So it is the retrieval is doing a pretty good job, and also the language model is doing a pretty good job in summarizing and giving us the relevant information. So let's do testing on different metrics, like ask how many sessions did we have. There were 5 sessions held at Inventures. It is absolutely wrong, and you probably know by this time why. Because by default, we retrieve 4 documents and pass that to the language model to answer the question based on that. But this quantitative question is we are not able to answer that with the Raptor model. The Raptor model was doing a pretty good job in answering qualitative questions. But in quantitative questions, it is not doing well, because obviously we are not passing all of the documents. We are only passing 4 closest neighbors to answering this question. We will later address this problem. Let's go and ask another question. How many sessions had a speaker named Laura? Laura was a speaker in at least 2 sessions at Inventures. So the model is not able to answer that correctly. So if you have a sensitive application that you need the accurate and exact number, we need to think about that and come up with an idea that I will discuss in the next videos. So the next question, who are the people working at the same company as Laura does? So Laura works at the same company as Dame, and who is CEO at Dame Ventures. So it is not answering that correctly at all. So the model was answering qualitative questions, but falling short on some questions that they were asking about the exact information, the exact numbers, and we will address that later. But we are not done with the deployment yet. We need a nice UI. And for the UI, I'm going to use streamlit and local tunnel. A streamlit is for the UI, and local tunnel is a library that allows us to expose one of the ports of our instance running on Google Colab to the world, so that we can interact with the application running on Google Colab without any need to install anything on our computer. And I have to mention that for the last part of my code, which I am using here, is inspired by the great repository from Javier. I highly recommend you check that out. I will put the link in the description. I read his code and familiarize myself with local tunnel. So let's get back to the second notebook that I have here, and everything is exactly the same as the previous notebook, but I have to mention that when you run the libraries, you have to come here and store this cell in mylibs.py file, so that later we can import that in our application. So first of all, uncomment that and run this cell, and then comment this out and write this cell in mylib.py, so that we can later import that in our application. Alright, so everything is exactly the same like the previous code that didn't have any UI, but for this part I have put the functions in the last part as an application app.py, so that later I can run that with the streamlit. I have modified the code a little bit so that it can be optimized for performance. For instance, I am loading the models only for the initialization, and not every time that a request is being sent to the streamlit application, and also a little bit more modification here, but the code is pretty much like the code that we had in the first notebook. So once you have the libraries loaded up, you run this cell, and then it will store the code that we have here in app.py, and then we will go and run this with the streamlit and store so right now streamlit application is running in the background. With this ampersand, we send that into the background and also redirect the output, the logs, into log.txt file here. And curl is retrieving the IP address of this instance that we have here. And then later we use local tunnel to expose one of our ports to the world so that people can interact with our application running on Google Colab. So let's enter the IP address, click on submit. You have to wait a little bit for the first time so that the server can load up and spin up, but this is only for the first time. And whenever you are interacting with the server for either you or other users, we don't have this wait time, which is around like 10 seconds. All right, and also you can deploy this nice UI easily on your server or on Streamlit servers. So let's ask one question that we asked previously. Let's ask, tell me about the topics discussed at InVentures. It is doing a pretty good job in terms of speed. It retrieved the answer pretty quickly, and it is relevant. And that's it about the UI part. And the good news is you don't need to install anything on your server. Everything is on your system. Everything is running on Google Colab, and also you can easily deploy that on your server for production mode. In conclusion, we don't have an omniscient person or system, and we are never going to have that in the future. Why? Because we are on a never-ending cycle and journey of discovery and generating more data, and we need to know how to draw insight from this data, and we need to know how to answer our question, how to find the relevant information. And for this purpose, we need to leverage and utilize technology, the AI tools, because we cannot set them aside. They are right now part of the game. And for the benefit part, for the solution part, we introduce RAG system that can operate on your local documents, either your personal documents or the documents that you have in your department, your company. And our system was doing a pretty good job in qualitative questions and was able to hold a candle to my own human-generated summary. At least it was as good as my human-generated summary, considering that I had more data than the LLM model that I used. But obviously, this system needs more improvement, especially on the quantitative questions, like how many sessions did we have in this event. I will address this problem in the next video, but for now, I think we have done a great job in retrieval. We discussed that when we send the query, we fetch the exact session, and also we did a pretty good job in tailoring the information and summarizing and generating in a coherent and cohesive manner. So that's it for today's video. Hope you enjoyed, and if you enjoyed, please star my GitHub and stay tuned.